Hello students, we will be looking at lesson 13.4 today, which is looking specifically at triangles, and we've been looking a lot at their angles and the relationship between angles, but we're going to focus today on the different sides or the different lengths of the sides that make up a triangle. So we're going to answer questions like this. Could these lengths make a triangle? 5, 6, and 7, 2, 4, and 1, 10, 12, and 21, 14, 16, and 31. We're going to look at problems like that. But actually to start, we're going to use my high-tech example little pieces of graph paper that are different lengths. I'm just going to randomly choose 3 of these and let's see if we can make a triangle out of them. Let's get these 3. Could I arrange them in such a way that they make a triangle? Yes, I can. I want you to look at all these different pieces that I have here, and I want you to think about a combination of these little pieces that would not make a triangle, if any. I'll give you a minute to look at those, think through. There's lots that would work, but is there any that wouldn't? Let's go for the extreme example. Maybe you were looking at these. Why would these 3 not make a triangle? It's 3 sides. Well, the other part is that a triangle needs to have 3 angles, right? And if I'm connecting these at the point, these poor little stubby ones cannot reach each other. I could put it over here, but then it doesn't quite reach. I can swing this around, but then it's too long. So these 2 are too small, or this one is too long. What's another combination like that would maybe not work? What about these? This one's a little bit longer than this one, and this one's a little bit shorter. That still doesn't quite work, right? They can't reach each other. What's maybe a formula or something we could think up? So, because this is longer than these 2, but that can make a triangle. So what makes it work, and when does it not fit for these different lengths to make up the sides of a triangle? I'll give you a couple seconds to think on your own of the relationship between these. What if they were the same length? And what I mean by that is this one, I don't know if you'll be able to see it. That one is 4 long, and this little guy is 2. And then this one is 6. So they're closer to each other. Do you think that these would work to make a triangle? Let's see. Ooh, they're just a little bit. I can swing these down though, right? That looks more like a bar model, doesn't it? There's no space between them. They're just laying on top of each other. So if they're equal to each other, that doesn't actually work either. Now I've just got a line of different sides on top of each other. What if instead of this 2, I went just a little bit bigger and got a 3? That seems to work, doesn't it? So when these 2 sides add up and they're more than the longest side, then it works. Let's try that with something else. This one is 9 long. So if I got the 6 and the 3, would we expect for that to work? Well, 6 plus 3 is 9, so that's the same length. No, these end up just making 2 lines on top of each other. Or even worse, if I did the 6 and the 2, they can't even touch each other. They're too far apart. But the 6 and the 4 add up to be 10. Ooh, that's more than 9. It's a pretty slim, obtuse triangle, but that time it works. And now that's where we reach our, I guess you'd say, equation or our pattern. No one side is longer than the sum of the other 2. No one side is longer than the sum of the other 2. And if we bring these back, that makes sense. We know that 4 isn't more than 6 and 9 combined, right? It's smaller than both of them. Same with 6. 4 is smaller than 6, but 9 is bigger. Those are greater together. But 6 and 4 combined, that's 10. That's barely bigger than 9, but it is greater, so that works. As opposed to when I used little 3. 6 and 3, that's not greater than, and I end up with 2 lines laying on top of each other. That's no good. I would actually encourage you to get some Legos or something else that you can measure out, or cut your own high-tech graph paper and measure that out. Try and see if you can make a triangle with one side that is the same length or longer than the sum of the other two. And you're going to find that's impossible. So now let's look at these. Is any one of these numbers bigger than the other two combined? 5 compared to 6 plus 7. 6 plus 7 is greater. That's 13. Let's see. 6 compared to 7 plus 5. 7 plus 5 is bigger. And 7 compared to 5 plus 6. Yes. So our answer is there's no one side here that's greater than the other two combined. What about this one? 2 compared to 4 plus 1. That's equal to 5. 5 is greater, so that side's good. 4. 2 plus 1 is 3. Uh-oh, that side is bigger. If I got out my little examples, I don't actually have a one piece, but that one piece wouldn't be able to meet. So no, this triangle is no good. Does not work. This one, and maybe you've actually recognized the pattern now, that these two are the smaller sides, and so I don't have to pay too much attention to them. I can really just look at that biggest one. What is 21 compared to 10 plus 12? 10 plus 12 is 22, and 22 is bigger than 21. Barely, but barely is good enough. So, yes, this one will work. And what about this one? Let's compare the largest side, 31, to the other two combined. 14 plus 16 is 30. 31 is bigger. So will this one work? No, it does not work because one side is bigger than the other two combined. If I just looked at the 14, 16 plus 31 is greater than 14, so it works according to that side, works according to 16, but the 31 is bad news. It is too long of a side to work with those other two lengths. We actually can also use this information to help narrow down answers. So if you're following along on the book, this question is on page 210. They tell us that XYZ is a triangle. The XY is 11 inches and XZ is 19 inches. They don't give us the length of YZ, but we know that it's more than 26. And we have to find the possible lengths that could be YZ. So we know from what they told us that YZ is greater than 26. What is the greatest number that YZ could be while still working with a triangle? So it can't be bigger than these two combined. So 11 plus 19 is equal to 30. So if 30 is the sum of the other two sides, what is the biggest that YZ can possibly be? If you're thinking it has to be smaller than 30, you'd be correct. So 29 is the biggest it can possibly be. For these problem students, we're not going to worry about decimals or fractions. Let's just look at whole numbers. So 29, technically 29 and a half would also be less than 30. But to simplify, we're going to look at things in whole numbers. 29 has to be bigger than YZ, otherwise it won't be a triangle. And we know it has to be a triangle. So what numbers would work here? Ooh, sorry, I should say that it has to be less than 30. Because 29 works, right? So it could be 29, that's less than 30, and it also is more than 26. It could be 28. It could be 27. But it can't be 26, just because we know it's bigger than that. So any of these three are possible answers. Doesn't that feel a little bit weird for a math problem to say 3 possible answers? But that's what they're looking for here. They just want to know what lengths could work. Okay? Your homework for this lesson is pages 133 to 136. You are going to need a ruler so you can measure some lengths and check out these triangles and make sure that they work. If you have questions about the concepts, of course, send me an email or have your parents give me a call. But otherwise, I hope to answer them on the Skype session or on the homework review afterwards. Thank you.